transcript, isn't it? Because you actually can withdraw. Well, you can withdraw from Riverland and take a withdrawal right now still. So let's say she's like, hey, I don't want to do this. You can take a withdrawal from Riverland and just get a withdrawal. But if you drop from the high school right now, you take an F for your high school transcript. So you only get like 3 days from the high school. And I don't make that decision, so I apologize. Here we go. Trigonometric functions and real numbers. We start with this. Anybody know what this is right here? Sine of theta. And we spell it like this. Okay? The actual word sine comes from, well, it was mistranslated. Many years ago, when they were making up sine charts and trigonometric charts, they actually were, doing astronomy, and they would have this angle in here, and in order to figure out, some properties of the angle and the circle and everything, they would divide it in half and that chord in half. So the term sine actually means this half chord. You don't want to write this down. I'm just going to erase it. However, it got mistranslated. It got translated, I think, from Greek to Arabic. Then went from Greek to Latin. They mistranslated it. And instead of coming up with the word for half chord, they came up with the word for sinus, or like your nose. So it was totally a mistake. When you see the word sine, it actually has to do with your nasal passages more than it does anything mathematically. Total mistake. If you want to know more about it, I wrote a 10-page paper a couple years ago on it. So I've got a copy right on my hard disk drive. I'll give it to you later. Some people said they would like to do a little light reading over break. I think that they were joking. I don't think they were being honest. So, nobody's read it yet. Well, my sister did. My eldest sister, she reads all my papers for me. I'm very, very happy that she does that. I know it wasn't very interesting to her, but she read it nonetheless. So if you are in the unit circle where you have x, y, and this is theta, the measure of the angle. In the unit circle, what is your r value? R is equal to what in the unit circle? 1. And the way that we define sine of theta is it has actually measurement properties. We take whatever the y value is and we divide it by r. Now in the unit circle, if r is 1, then y over r is equal to just y. What do you think this is? Cosine of theta. Cosine of theta happens to be the x value divided by r. And if we're in the unit circle and r is 1, then cosine is equal to x. Tangent of theta. Tangent's equal to y over x. Let's think about that. Y is my rise, x is my run. Rise over run, it's the same thing as slope. Tangent is the same thing as slope. It ends up being, okay. This is cosecant. And cosecant has a relationship with sine. In fact, cosecant is the reciprocal of sine. So what's the reciprocal of y over r? Over y. And secant of theta is the reciprocal of cosine. So it's going to be r over x. And the last one, cotangent of theta. What is the reciprocal of tangent? X over y. What do you think? Any questions? Okay. got a couple more pieces we need to write down then, okay? Sine of theta, we said, was the reciprocal of cosecant. So we could write it as 1 over cosecant. We know that that relationship is true. Therefore, cosecant of theta is equal to what? Cosecant is the reciprocal of sine, so it's going to be 1 over sine. If they're reciprocals, you can just write 1 over it. That's what it means to be reciprocal. Go on the bottom. Cosine of theta is equal to 1 over what? Secant. And secant of theta is equal to 1 over cosine. Tangent of theta is equal to 1 over cotangent. And cotangent of theta is equal to 1 over tangent. Question. Co means with, and so that helped determine how they came up with those simple terms. That's a long explanation. Secant actually has to do with a chord that passes through a circle and touches on 2 spots. So I'll give you a geometric representation later. I want you guys to know that all these formulas you will have on the test. All these relationships I will give to you. Okay? You don't have to memorize these parts. Okay? So that's something you will be able to see. But now you can see exactly where they came from. One last piece that we need to state, though. Okay? This relationship right here. Tangent of theta is y over x. Okay? What is also equal to y? What's equal to y? Sine. What's equal to x? Cosine. So tangent can also be written as, because it's y over x, it can also be written as sine of theta divided by cosine of theta. That is an extremely important property that you will use very often for the rest of trigonometry. And cotangent, if it's equal to x over y, we can write it as cosine of theta divided by sine of theta. Little resistance sometimes from people about some of the terms. For example, they don't want to say sine of theta, they want to say sin. They don't want to say cotangent, they want to say cot. And they don't want to say secant, they want to say sec. You know, and they were wondering, you know, is that okay if we just refer to it that way? And I said, I don't know anybody who's ever done that. So I guess, you know, if you want to, it's up to you. Go ahead. But we call them by the names that they're given. So just kind of get used to them. But there they are. So lots of formulas. And the thing about trigonometry is you can continue to derive more and more and more formulas, and we'll continue to do that. These are just the basic ones, and we'll get used to working with these. We are going to use just about all of these formulas right on this first example, okay? All right, it says draw a picture and use special triangles to calculate the exact value of the following trigonometric functions. Okay? On your assignment, you will simply give one answer. We need the practice right now, so we are going to do all 6 for the given theta value. So in this case right here, we have theta is equal to pi over 3, and we want all exact values of the 6 trigonometric functions. So we'll now take the notes that we had and we'll put it into practice with the example. Sine of theta, cosine of theta, tangent of theta. There we go. We have all 6. Now what we need to do is we need to locate pi over 3, and then we need to draw a special right triangle. Where is pi over 3 located? 60 degrees. So I move up right here to 60 degrees. I have a special triangle of 30, 60, 90. What is the radius? 1. What is going to be the bottom length? 1/2. And what do I do to that bottom length to get the other length? I multiply by the square root of 3. And so we get square root of 3 over 2. And here we go. This is a coordinate. Some people don't like this, and that's all right. I was trying to figure out why they may not like it, but that actually has a coordinate. So we're talking about really a terminal point here. This is a coordinate of 1/2 and root of 3 over 2. And you know that your r value is equal to 1. And you'll see why that's important when we do example C. But, you know, some people feel like they wrote it down twice. I guess maybe that's the case. Sine of theta is equal to y divided by r. So if I take my y value and divide it by my r, what do I get? Square root of 3 over 2. Any questions how I did that? Okay, by our definitions up above, you have cosine of theta is equal to x over r. So it's going to be 1/2. How do you get tangent? Yep, y divided by x. I take my y value, divide it by my x value. So I take the root of 3 over 2, and I divide that by 1/2. How do I divide by 1/2? Multiply by the reciprocal, so multiply by 2 over 1, and you get the root of 3. We have square root of 3 over 2, we have 1/2, and we have the root of 3. Those are my values. Now we need the other 3. So we're going to think about the relationship that we laid out at the top. What's the relationship between cosecant and sine? They are reciprocals. So all I need to do to figure out cosecant is take the reciprocal of sine of theta. What's the reciprocal of square root of 3 over 2? 2 over the root of 3. Can you leave the root of 3 in the denominator? Nope. So we rationalize the denominator. We get 2 roots of 3 over 3. What's the reciprocal of 1/2? 2. Cotangent. What is the reciprocal of the root of 3? 1 over the root of 3. Multiply top and bottom by the root of 3. Root of 3 over 3. Those are my 6 questions. Very good. So in your book, for your first few problems, you are only going to list square root of 3 over 2. That's all you would put. If it's not a special triangle, we don't really know how to find some of the lengths. I mean, the only reason we knew that this was square root of 3 over 2 and this was 1/2 is because it made it 30, 60, 90. Yep. It's just we weren't able to come up with the lengths otherwise. So the purpose of this is to connect. Have we made these special triangles before? Yeah. So we're going to, build that back in our brain once again. find that terminal point, and using that terminal point, we then write this. So we've done all this before. Now we're just writing the ratios. Okay. All right. Now, so over time, I've gotten better at kind of guessing what examples people need and what they don't. This wouldn't be as helpful as this. Let's do cosine of negative 5 pi over 4. You guys are going to like that one. And then we're going to do tangent of 3 pi over 2. Those will connect well for you. The reason why I started, at first we just did one of each. You know, I was like, okay, well that's no big deal. And then I saw that there was a lack of practice. We needed to practice more of them. So when we get to the last problem of our notes today, you guys will feel much more confident going into it compared to what you would have felt like if we hadn't done all this. So we try negative 5 pi over 4. Let's list all 6. Sine of theta, cosine of theta, tangent of theta, cosecant theta, secant of theta, tangent of theta. Negative 5 pi over 4. Which quadrant does that bring me to? Second quadrant, because 5 pi over 4 is how many degrees? 225. So you're going to go 225 in the counterclockwise direction. So if you do the conversion, 5 pi over 4, 225 degrees in the opposite direction. That means I start here and I go negative 180 and then negative 45 more. This is going to be a 45, 45, 90 triangle. I know the radius is 1. If you have a 45, 45, 90, what do you do with the radius to get the other side? Yeah, it has something to do with the root of 2. And if you had the bottom side, you would multiply by the root of 2 to get the radius. But now you're going to divide by the root of 2 to get this. If you remember, that came up to be the root of 2 over 2 when we rationalized the denominator. Okay, what is the coordinate? What's the x-coordinate? Negative root of 2 over 2. Because we're in the second quadrant, the x value is going to be negative. Y value? Root of 2 over 2. Now we can go to work and list all of the 6 trig functions. Sine of theta is going to be y divided by r. What's y divided by r? Root of 2 over 2. Cosine? Negative root of 2 over 2. Tangent. What do? You take y divided by x. Y divided by x. What is root of 2 over 2 divided by negative root of 2 over 2? Negative 1. Now that I got these 3, I just take the reciprocal for the other 3. Let's try the easy one. What's the reciprocal of negative 1? So we got negative 1 over 1. We take the reciprocal. We get 1 over negative 1, which is negative 1. Now I got to take the reciprocal of the root of 2 over 2. So I'm going to have 2 over the root of 2. Rationalize the denominator. Two roots of 2 whoop, over 2. 2's cancel. Get square root of 2. And what's secant? Negative root of 2. Yep. Done and done. Look at your graphic organizer I gave to you, okay? Let's see, this angle right here, so I don't write the negative angles down. That'll be 135 degrees. That would be that spot. Look at 135 degrees and follow it all the way over. See how your values are all filled out just like we did? So those are important values. We'll continue to use them constantly through trigonometry. Some people actually memorize them. If you ask somebody what the sine of 3 pi over 4 is, they could tell you it is the square root of 2 over 2. Yeah, so that's helpful as you move forward. Or at least be able to construct the triangle or have an understanding of why you got what you got. Okay? All right? Any questions before I move on this one? This one's easy. Okay. Let's do it. Three pi over 2, where does that bring me? 270. So I start here and I go around, yada, yada, yada. Now, people who draw triangles, all of a sudden it's like, well, you can't draw a triangle. Or they start drawing a funky triangle that you know, doesn't really work out. This means nothing to you. We just want the location of that coordinate. Where did we end up? We ended up at 0, -1. That's our location. That's our x value and that's our y value. Write them all down. Usually by this point, and nobody said it today, usually somebody says, I'm tired of writing cosine and sine and tangent and cotangent. How would I answer that? See this radius right here? The radius should always extend from the center out. And this is what you're calling your radius, and it's not a radius. In fact, it has a value greater than 1. The value of that radius is the root of 2. And so making a triangle does absolutely no good to you. It does not help you at all. I mean, I guess this side is 1 and that side is 1, if that helps you. But all we want is that location, and we can plainly look at that spot and say the location is 0, -1. The only reason we make the triangles is to find the location. That's the only reason we do it. So sine of theta is equal to y divided by r, which is going to be -1. Cosine is going to be x divided by r, which is 0. And tangent is y divided by x. -1 divided by 0 is undefined. Can't have 0 in the denominator. For cosecant, I take the reciprocal of sine. What's the reciprocal of -1? -1. Secant, I take the reciprocal of 0. Yeah, the reciprocal of 0 is undefined because 0 over -1, that's 0, right? If you take the reciprocal, you would get 1 over 0, which is undefined. So 0 and undefined are reciprocals of each other. So the reciprocal of 0, you said, was undefined. And in order to find cotangent, I would take the reciprocal of tangent. What's the reciprocal of tangent? That was a nice one, wasn't it? All right, we're ahead of schedule. Got, oh, we don't want to do that one. Oh, that one right there. Okay. We'll do these two and then example 3a. It says the terminal point determined by t is given. So we don't even have to find it. We don't have to find it. Okay? There's not a special triangle that gives us a terminal point of -5, 13 and 12, 13. So they just give us that as an xy coordinate. Okay? X, y. It says find sine of t, cosine of t, and tangent of t. So we're just going to do those three. Sine is equal to y over r. Do you know what r is? That's a good question. Are we in the unit circle? Tough to know until we check, isn't it? Let's check. Do you remember the equation for the unit circle? X squared plus y squared is equal to 1. Let's see if that holds true for this point. What's negative 5 over 13 squared? Over 169. What's 12 13 squared? 144 over 169. And you get 169 over 169, which is 1, right? So this is the unit circle. So the radius is equal to 1. That's the one we'll do next. Sine of t is going to be what? It's y divided by r, so 12 divided by 13. Cosine? Negative 5/13. How do you figure out tangent? Take y, which is 12/13, and divide it by x, negative 5/13. 12/13 divided by negative 5/13. What do I do? Multiply reciprocal. I heard somebody say negative 12/5. You're correct. Multiply by reciprocal. You see the 13s go away, and you get negative 12/5. So everybody asks, what if you weren't in the unit circle? I'll give you an example, okay? Let's use this one, negative 8/15. Okay. Now, but this is a good question because, you know, this really kind of splits people. Some people look at that and they know right away that you're not in the unit circle. Other people look at it and they don't know if they're in the unit circle or not. Why is it obvious that we are not in the unit circle? Yeah, you have to have values that are smaller than 1. I mean, if you go to, think about the unit circle, it sits right there with a radius of 1. You're talking about the point negative 8/15, so back 8 and then up 15. So you see that point is not in the unit circle. It's part of a much bigger circle with a different radius, okay? So we have our x value. Hey, don't do that. We have our x value, we have our y value, but we don't have r. We need our radius. X squared plus y squared is r squared. What's x squared? 64. Y squared? +64 plus 225 is 289. 17. We have our x value, we have our y value, we have our r value. We can now write down all of our functions. And it says for this problem it just wants 3, so we're going to just write down 3 of them. What is the sine of t going to be? Yep, sine of t is going to be 15 over 17. Cosine? Negative 8/17. And tangent? Negative 15 over 8. Negative can go on the top, on the bottom, or in front. You just need one. So. Yeah? You do this stuff, right? If you can do the next problem, you are golden for the test. I mean, if you can do the next problem, you've got a legitimate shot at acing the test. Okay? I'm not kidding. If you can follow today's lesson, you've got a shot to ace the test. Let me just show you this part. sine is y over r. Where are the y values positive in the coordinate grid? Y values are positive where? Which quadrants? 1 and 2. So sine's positive there, and sine's also positive there, because it's y divided by r, and your y values are positive up there. Where cosine is x over r, where are cosine values positive? Where is x positive? X is positive in the first quadrant and the fourth quadrant. Okay, x is positive over here, y is positive up. Tangent is y divided by x. So tangent's positive in the first quadrant because they're both positive, and it would also be positive in the third quadrant. So you can see on your organizer, I show you which ones are positive and where they're positive. Here's how some people remember this, okay? I never thought of this. I heard this when I came to Albert Lee, and people said, well, that's what we always said. I guess. All of them are positive here. So all seniors take calculus. So that's supposed to be a reminder that if you're going to be senior next year, you're supposed to sign up for calculus. I've never said that except for introducing it here. So some people love it. They're like, oh yeah, all seniors take calc, and that's how they remember it. More power to you. Great. How do I remember it? I think sine is y over r. Where is y positive? Up. Cosine is x over r. Where is x positive? Over here. Tangent is both divided. There. I think of where it came from. So if you want to remember, all seniors take calc. There you go. Got it. Okay. We're going to use it for this next one. Find the values of the 6 trigonometric functions given the following information. We have sine of t, cosine of t, tangent of t, cosecant of t, secant of t, and cotangent of t. We need to find all 6. The information we know is this. Sine of t is equal to -4/5, and we know that t resides in the third quadrant. So I ask you, if you are in the third quadrant, which is the only one that's positive? Tangent is positive. If tangent is positive, so is its inverse, cotangent. The others are going to be negative. We happen to know already one of the values. Which value do you already know up here? Sine of t is equal to -4/5. They tell it to us. If we know sine of t, which other value do we automatically know? Cosecant is going to be the reciprocal, so it's going to be -5/4. Oh, what to do, what to do, what to do. Are you ready for the aha moment? Yes. That's one way. That's one way to do it. And I used to teach it like that, and it got me in trouble. So think of that and run with it. But I'm going to show something else at this point. Okay, that definitely connects as well that we have to use. You can derive what you're thinking of from the formula I just showed you right now. Would you guys all agree that x squared plus y squared is equal to 1 in the unit circle? Do you remember we gave a different name for x? X is the same thing as cosine. And y is the same thing as sine. So we can write ourselves a new formula. Instead of x squared plus y squared is 1, we can write cosine squared. And we write the squared over the cosine so we know we're not squaring the angle. Okay. Plus sine squared is equal to 1. Now we've got a formula we can use. I never write it like that, and it's not written like that in any books. They always write it like this. So addition is commutative, so we can switch it back and forth, but that's just the way it's always written. So, and it's ingrained in my blood, and I will continue to write it like that. So if you want to write it like this, go ahead. Freedom of choice. Taylor's going to choose that. Yep. All right. That's fine. You go ahead. All right. So if I know this formula, what value can I now solve for? Now I can solve for cosine. So let's do that. Cosine squared of theta plus, what is sine squared? What do we get if we square that? If you square negative, it becomes positive. 16 over 25 is equal to 1. So now what am I going to do to both sides? Yep, subtract. So I'll write it like this. So we all see we got 25 over 25. We subtract that 16 over 25 and we get (9 over 25). Now what do you got to do to both sides? Square root. When we square root, how many answers do you come up with? 2. Cosine theta is equal to plus or minus 3 over 5. Do you know whether it's the positive or the negative? Yes, how do you know? We've already decided based on the third quadrant and our all seniors take calc idea. So we know that cosine was negative, so we make it negative 3/5. If you know cosine is negative 3/5, what is secant? Negative 5/3. Now we've got the last two. Oh boy, there was a formula we learned. Yeah, Scott sees it. There was a formula we learned right back at the beginning that tangent of theta was equal to sine of theta divided by cosine of theta. So now we can use that. Tangent of theta equals sine of theta is negative 4/5. Cosine of theta is negative 3/5. I divide. When I divide, I should multiply by the. And I now cancel off 5s. I get a positive 4/3. You know it should have been positive because you marked it accordingly. Therefore, what is cotangent? 3/4. Done and done. I'm not saying it's all got to sit up in the brain right now. That's why I practice it. But do you see the connectedness? Do you see how many different relationships there are that exist? And it just continues to grow and grow and grow. For your assignment, don't do all 6. So just like I told you in class, you don't have to write 6 answers. You'll just need to do 1 answer for each one. So if it says sine of pi over 3, don't write all 6 down. Just write, it's the square root of 3 over 2, okay? And don't just use your sheet. Don't just look off this sheet, okay? Make your little triangle, because that's what you're going to have to do on the test. Then do 23 through 30 for 61, 62. That's where you're supposed to do all 6, okay? Please start working on this tonight. You're going to have time all day Thursday to ask questions on your study guide. Tomorrow will be, should be a pretty good day. I think you guys will do really well with tomorrow's stuff. So, Quinn first, then Caitlin.